Hi there, Kim fans, and welcome to our review of topic 7.6, Properties of the Equilibrium Constant. For this review video, I have given you a generic chemical equation that is shown at equilibrium, substance A reacting with substance B to produce substance C and substance D. And again, this reaction is at equilibrium, and the equilibrium expression is given right below with the equilibrium constant equal to the products concentrations divided by the reactants concentrations. So what we're going to look at is what happens if you change this reaction in some way. What will that do to the equilibrium constant? So I've given you three different ways that we could change the reaction. One, if I wrote this equation in terms of different coefficients. In other words, the coefficients have to be a certain ratio, but what if I multiplied all of those coefficients by some multiplier? So what if I multiplied all of the coefficients by some multiplier E? That would be the same ratio, the same mole ratio, but what would that do to the equilibrium constant? Well, all of these exponents would also be multiplied by E, which means that your overall equilibrium expression would be, or equilibrium constant, would be raised to the E power. So whenever you multiply the coefficients by some factor, K is raised to that factor. What if we reverse the reaction? What if we wrote the reaction this direction, where substance C is reacting with substance D to produce substance A and substance B? What would that do to our equilibrium constant? Well, since we're flipping the reaction, we would flip what's in the denominator and what's in the numerator. And so that is simply going to give us the inverse of K. So whenever you reverse the reaction, your K value is just going to be the inverse of the original K value. What if the reaction is a sum of multiple reactions? In other words, what if you have multiple reactions that are going together to add up to this overall reaction? And each one of those reactions has its individual K value. So we have a K value for the first reaction, a K value for the second reaction, and those reactions add up to an overall reaction. Then our K value for the overall reaction is simply going to be the product of those individual K values. And so the product of the K values is going to give you the overall K value for the reaction. What I've just done for all the equilibrium constants is also true for Q. Remember, Q is the exact same expression as K. And so whatever I've done for K in these manipulations, we would also do for Q. Hopefully that just gives you some background on K and properties of the equilibrium constant. If you have any questions, of course, please let me know, and I'll be happy to help you out. Good luck.